Imagine sailing through the North Atlantic on a quiet gray morning. Then the sea explodes. Not a storm, not a wave. The ocean itself tears open, and fire pours out from underneath it. A column of ash climbs 9 kilometers into the sky. Lightning cracks inside the smoke. The fishermen watching this can only think of one explanation. A ship must be burning, but there is no ship. The ocean floor is cracked open, and something ancient is pushing its way into the world. A new island is being born, not over millions of years, hidden from every eye, born in real time, in front of a boat that had only come out to check its nets. Within hours, black rock breaks the surface. Within weeks, it has a name, Surtsey, named after a fire giant from Norse myth said to burn the world at the end of time. Scientists rush toward it. Pilots fly low through the ash to photograph it. Geologists board boats, not knowing if the new rock will even hold their weight. And then, while the island is still erupting, Iceland does something almost no country has ever done with new land. They ban people from it. No tourists, no settlers, not even a footprint that doesn't belong to an approved scientist. For all of history, when new land rose from the sea, people rushed to claim it. This time, they chose to leave it alone. That decision still stands today. Fewer people have stood on Surtsey than have walked on the moon. Every scientist who lands there is checked, in case they're carrying something as small as one seed on their boot. Because of that choice, Surtsey became something almost nowhere else on Earth can offer. A blank page. A chance to watch from hour one exactly how life crawls onto a place where nothing has ever lived before. So the real question isn't how this island was born. It's what keeping the world out let scientists finally see. How does an island appear where nothing existed before? To understand what happened on November 14, 1963, you have to go back further, back to the seafloor itself. Iceland sits in one of the strangest places on the planet. 2 massive tectonic plates, the North American and the Eurasian, are pulling apart beneath it, inch by inch every single year. Underneath that, a plume of molten rock rises from deep inside the Earth, like a blowtorch aimed at the crust from below. 2 forces, both pushing magma toward the surface. This is why Iceland has more volcanoes than almost anywhere on Earth. But south of the mainland, there's a chain of islands called the Vestmannaeyjar. And for 5,000 years, this particular stretch of seafloor had been silent. No eruptions, no warning signs, just dark, cold ocean, until the night of November 8, 1963. 300 feet below the surface, a crack opened in the seafloor. Magma began forcing its way up through solid rock. And for 6 days, nobody on the surface knew. Then on the morning of November 14th, the crew of the fishing boat Islifer 2 noticed something wrong with the water. Smoke rising from the sea itself. They radioed it in as a ship fire. It was the only thing that made sense to them. It wasn't a ship. It was magma colliding with freezing seawater, and the result was one of the most violent kinds of eruption on Earth. Scientists call it phreatomagmatic. It happens when molten rock meets water, and the water instantly flashes into steam. That steam doesn't just rise, it explodes, shattering the magma into fine ash and hurling it thousands of feet into the sky. This eruption style is so distinctive, geologists gave it a new name, Surtseyan, named after the very island that was, at that moment, still being born. Pilot Sigurd Jan Einarsson flew toward the chaos and did something remarkable. He photographed it. From the air, through smoke and falling ash, he captured humanity's first real look at a planet actively manufacturing land. Volcanologist Sigurdur Thorarinsson organized teams to document every explosion, every tremor, every shift in the plume. What they were watching hour by hour was violence turning into geography. By early 1964, something changed. The island had grown tall enough that seawater could no longer reach the vent. The explosion stopped, and what came next wasn't fire and steam anymore. It was something slower, quieter, lava, pouring out in wide, glowing sheets, sealing the loose ash beneath it like armor. Scientists later discovered this hardened rock had transformed in an extraordinary way, developing the same rare mineral structure found in ancient Roman concrete. Nature, with no engineers and no blueprints, had built something almost indestructible. For 3.5 years, Surtsey kept growing. By the time the eruption finally stopped in June of 1967, the island stood 170 meters tall and covered 2.5 square kilometers of solid ground. Ground that 6 years earlier had not existed anywhere on Earth. Word of the eruption spread across the world. Newspapers called it a miracle. Scientists called it something else, an opportunity that might never come again. Because now standing in front of them was a piece of land completely empty of life. No plants, no animals, no history, nothing. And that emptiness was about to make a small group of Icelandic officials do something almost no government had ever done with newly formed land. Instead of opening it up, they were about to shut it down. In 1965, while ash was still falling in places on Surtsey, a small hut stood near the research camp, simple, wooden, built only to shelter scientists between expeditions. One day, someone walking past it noticed a strange splash of green against all that black volcanic rock. A tomato plant, small, stubborn, and completely alive, growing where nothing should have been growing at all. Nobody had planted it on purpose. The most likely explanation was almost embarrassing. A seed, dropped from someone's lunch, had landed in the ash and sprouted. The scientists didn't celebrate it. They pulled it out immediately. To an outsider, that might sound extreme. It was one tomato plant, harmless, even kind of charming. But to the researchers standing on Surtsey, it represented something far more dangerous than a stray vegetable. It represented contamination. So here's the question worth asking. Why would a single tomato plant on an empty volcanic island be treated like a crisis? The answer goes back to a decision made 2 years earlier. While the eruption was still happening, in 1965, the Icelandic government declared Surtsey a nature reserve. Not after the lava cooled, not after the danger passed. While the island was still actively forming, UNESCO later described exactly why this mattered, calling Surtsey a place that had been protected from its birth, giving the world a pristine natural laboratory for studying how life begins. A laboratory with no walls, no glass, no control switches, just an empty island and a law standing guard around it. And that law was strict, brutally strict. No one could land on Surtsey without written permission from Iceland's Environment Agency. Fishing boats couldn't drop nets in the surrounding waters. Divers couldn't explore the shallows without approval. Even carrying a firearm near the island was against the law. But the rule that mattered most was simple. Nothing alive goes in. No seeds, no insects, no soil. No plants carried in on purpose or by accident. Every visiting scientist had their boots and gear checked, because a single hitchhiking seed could quietly rewrite the results of an experiment 60 years in the making. Leave nothing behind either. No tools, no trash, not even human waste. Whatever you bring to Surtsey, you carry back out. To most people, this might sound like overcaution. To scientists, it was the entire point, because Surtsey wasn't just an island anymore. It was a question frozen in time. If life managed to take hold here, every single arrival, every seed, every insect, every bird, would have gotten there through nothing but wind, ocean currents, and the will of nature itself. No human shortcuts, no accidental cheating. For decades, that promise held. In 2008, UNESCO made it official, naming Surtsey a World Heritage Site, recognizing it as one of the purest natural experiments left on the planet, which meant the real work could finally begin. Because an empty island, sealed off from human interference, was about to face its first true test. Something was going to have to survive out there, on bare, black, sterile rock with no soil, no shelter, and no second chances. The only question left was, what could possibly go first? How can life survive where there is no soil? In 1967, when the eruption finally stopped, Surtsey was as close to sterile as a piece of land can get. No dirt, no roots, no decay, just black basalt, ash, and raw volcanic rock still warm in places, cooling under the North Atlantic wind. By every normal rule of biology, nothing should have been able to live there for a very long time. But scientists already knew something the island didn't. Life doesn't wait for permission. The first arrivals weren't plants. They weren't even visible to the naked eye. As early as 1964, just 1 year after the eruption began, researchers found something strange. Growing in the damp cracks of Surtsey's, rock molds, bacteria, fungus. They had arrived on the wind or in sea spray, invisible passengers riding air currents across open ocean. And once they landed, they got to work immediately, breaking down minerals in the rock, starting a process that would take decades to finish, the beginning of soil. Next came something slightly bigger, lichens and mosses, tough enough to grip bare stone with nothing to hold onto but the rock itself. The first 2 moss species were recorded on Surtsey in 1967, the same year the volcano fell silent. By 1971, that number had climbed to 36. Each one trapped a little moisture. Each one caught a little dust. Slowly, without soil, they were building the beginning of soil, but the real breakthrough came from the sea. On June 3, 1965, botanist Paul Fredriksson stepped onto a sandy stretch of Surtsey's shoreline and found something no one expected to see for years. A single sea rocket plant, Curio maritima, rooted, alive, growing directly out of black volcanic sand. Its seeds don't fly on the wind. They float, carried by ocean currents, sometimes for hundreds of miles, until they wash ashore somewhere new. Surtsey had just become somewhere new. It was the island's first flowering plant, discovered less than 2 years after the eruption that created the ground it was standing on. Around the same time, something even smaller was making the same journey. In a completely different way, insects, flies, beetles, spiders, carried not by wings but by silk. Scientists studying volcanic islands have long observed a strange pattern. Often, the very first animal to reach fresh lava is something like a wolf spider or a cricket, arriving by accident, floating on threads of silk through open air, a method researchers call ballooning. On Surtsey, this wasn't theory. It was happening in real time, documented year by year, as tiny colonizers rode the wind onto rock that had been part of the ocean floor just months before. By the early 1970s, Surtsey had bacteria breaking down stone, moss holding onto bare rock, a flowering plant rooted in volcanic sand, and insects moving across its surface. 4 completely different forms of life, 4 completely different ways of arriving, all of them uninvited, all of them unstoppable. And yet, every scientist studying the island knew this was still just the beginning, because soil, moss, and a few scattered plants weren't going to be enough to transform Surtsey. Something bigger was coming, something with wings that wouldn't just visit the island, it would rebuild it. February 1964, 3 months after, Surtsey first broke the surface of the sea. A small boat rocks against rough Atlantic swells, carrying a team of scientists toward an island that technically shouldn't be stepped on yet. The rock is still hot in places. Steam hisses up from cracks in the ground. Nobody knows for certain if the ground beneath their boots will hold, or if it might collapse into the sea the moment they put their full weight on it. Leading that team is volcanologist Sigurdur Thorarinsson, a man who would later be remembered as the father of modern Icelandic volcanology. He steps onto Surtsey anyway. There's no safety manual for this, no previous expedition to learn from. Every choice, every step, is being made for the first time in human history. The scientists carry basic gear off the boat by hand, because there's no dock, no path, nothing but jagged volcanic rock waiting to catch and slice through boots. Instruments have to be protected from both scalding steam and freezing sea spray, sometimes on the same short walk. One researcher would later describe something as simple as swinging a hammer to collect a rock. Sample as an act requiring real caution. Hidden pockets of heat beneath the surface could turn a routine, strike into a burst of steam, right in your face. And yet, according to those who documented the earliest expeditions, there was something else running through the danger: excitement. Because almost no scientist in any field ever gets the chance to study a place at the exact moment of its birth. Above them, pilot Sigurjón Einarsson kept flying low passes over the island, capturing aerial photographs that would end up published around the world. Iceland's aviator Johannes R. Snorrason did the same, and decades later, NASA's Earth Observatory would credit him as one of the finest pilots the country ever produced. Between the pilots in the sky and the geologists on the ground, a new organization began to take shape. The Surtsey Research Society. Its entire purpose was simple to state and almost impossible to execute: study everything, touch as little as possible. For years, that meant documenting a landscape with almost nothing living on it. Then something changed. Within just a few years of the eruption ending, dark shapes began appearing along Surtsey's rocky shoreline. Not birds, not insects, seals. Gray seals and harbor seals, hauling themselves out of the freezing water to rest on land that hadn't existed within most of their own lifespans. By 1982, researchers confirmed something remarkable. Gray seals weren't just visiting Surtsey anymore. They were breeding there, an animal choosing to raise its young on ground that 18 years earlier had been molten rock exploding out of the seafloor. And where seals gathered, something else started circling offshore. Orcas, a food chain assembling itself piece by piece around an island that technically had no right to have a food chain at all. But the most dramatic arrival wasn't in the water, it was in the sky. By 1970, 7 years after the eruption began, northern fulmars and black guillemot started doing something no one on Surtsey had witnessed before. They landed, they stayed, and they began building nests. Scientists watching this moment didn't fully grasp what it meant yet. To most people, a few nesting birds on a barren island might not seem like much, but researchers studying primary succession knew better. They understood that birds don't just visit a place, they change it. Every bird that lands carries something with it. Invisibly, in its feathers, its feet, its droppings, its stomach. And Thorarenson's early teams, who had risked steam burns and unstable rock just to walk across Surtsey's surface, were about to watch that barren black island do something none of them had predicted. It was about to turn green. By the mid-1970s, something remarkable was happening on Surtsey that had nothing to do with lava or ash. Patches of ground were turning white, not with snow, but with seabird guano. Fulmars and guillemots had begun nesting, leaving behind thick layers of droppings that transformed the soil beneath them. For the first time, the island gained something fresh volcanic rock lacked: nitrogen, phosphorus, the nutrients needed for life to flourish. Scientists soon noticed a striking pattern. Where birds didn't nest, only scattered mosses and a few hardy plants survived. Where birds gathered, dense grass spread across the island. The soil became richer in carbon, and the vegetation looked like an entirely different ecosystem. By 1984, kittiwakes had established Surtsey's first permanent gull colony. That single event accelerated everything. In 1986, researchers recorded just 15 plant species. By 2008, that number had grown to 69. Same island, same harsh Atlantic climate. The difference was birds. But the biggest surprise was still to come. Many of these plants had seeds that couldn't float across the sea or travel on the wind. By every scientific expectation, they should never have reached an island 32 kilometers offshore. Then in 2025, researchers Paweł Wasowicz and Andy Green revealed the answer. Most plants hadn't arrived by wind or ocean currents. Birds had carried them, inside their digestive systems, on their feathers, clinging to their feet. As Wasowicz explained, birds were the true pioneers of Surtsey, transporting species scientists once believed could never reach the island. It reshaped decades of thinking about how new land is colonized. Surtsey had become the perfect natural laboratory. By the 1980s and 1990s, the transformation was undeniable. The barren black lava had given way to grass stretching above researchers' knees. One ecologist summed it up perfectly. Life does not move in isolation. It follows life. Plants depended on birds depended on fish, and beneath the waves, algae, limpets, and starfish were building an equally complex ecosystem. By the 2000s, Surtsey's oldest bird colonies resembled the nearby island of Elladi, a nutrient-rich grassland shaped by seabirds. In 2014, ecologist Borgthor Magnusson predicted that Surtsey would eventually follow the same path. It was a confident prediction, but nature had one more surprise. In 2012, something happened on this thriving, bird-built island that no one saw coming. In 2012, on an island that had spent decades turning green, something started dying. Researchers watched permanent vegetation plots wither. Grass that had taken nearly 40 years to establish began collapsing within months. The cause wasn't an eruption. It wasn't a storm. It was drought. An unusually dry summer pushed Surtsey's ecosystem backward for the first time, showing that primary succession could reverse. It revealed an unsettling truth. Surtsey wasn't just a natural laboratory. It was one that could break under conditions scientists hadn't predicted. And that raises a difficult question. If one drought can undo decades of progress, what happens as the North Atlantic becomes increasingly unpredictable? No one knows. But the drought wasn't the island's only mystery. In 2017, the Sustain project drilled deep into Surtsey's volcanic core, recovering rock untouched since the eruption ended. Inside, researchers confirmed that seawater had slowly reacted with volcanic rock to form a luminous tobermarite, the same mineral responsible for the remarkable durability of ancient Roman concrete. Without engineers or human intervention, nature had spent 50 years creating one of Earth's strongest natural building materials. The discovery answered one question and raised many more. If the island has been transforming beneath the surface this entire time, what else remains hidden? Above ground, the mysteries continue. Some of the bacteria and fungi that first appeared in 1964 are still poorly understood. Scientists know they helped create the island's first soil, but exactly which species arrived first remains unknown. Plants have offered surprises too. In 1998, researchers discovered a willow bush growing on Surtsey, not a seedling, a mature bush. No one could fully explain why it appeared so late. Even after decades of observation, the island was still defying expectations, and Surtsey itself continues to change. Since 1967, relentless erosion has steadily reduced its size. By 2012, the island covered only about 1.4 square kilometers, nearly half its original area. Geologists believe the softer outer layers will eventually disappear, leaving only the hardened, mineral-rich core. But no one knows when. Could one powerful storm erase decades of coastline? Could rising seas accelerate a process expected to take centuries? The island that once answered how life begins is now asking a far more difficult question. How long does Surtsey have before the ocean takes it back? Today, Surtsey covers roughly 1.3 square kilometers, less than half its size when the eruption ended in 1967. Its tallest point now stands at 155 meters. The coastline keeps shifting, sand building up on one side, cliffs collapsing on the other. And yet walk across it today, and you'd barely recognize it as the same place. Thorarinson's team once risked steam burns just to reach. 15 bird species now nest there every year. 89 species have been recorded visiting. Beneath the waves, kelp forests and starfish colonies have turned the shallows into their own thriving world. In total, scientists have logged over 300 species of insects and spiders alone, every one of them arriving without a single human hand involved. Geologist Marie Jackson, who led drilling expeditions into Surtsey's core, summed up why any of this still matters. "It's not often," she said, "that we have geologic processes we can watch change at the human scale. Surtsey," she said, "is very important in that regard, but that scale is shrinking." Climate scientists studying the island now factor in rising seas and stronger Atlantic storms, the same forces that triggered Surtsey's shock 2012 drought. Erosion that once seemed slow and predictable may not stay that way, which leads to the bigger question researchers keep circling back to: could this ever happen again? Iceland's ridge is still active. New vents could open tomorrow, or in a century. But Surtsey only became what it is because of one decision, made in the chaos of an active eruption, to protect it before anyone knew what it would become. If a new island rose from the sea today, would anyone move fast enough to do the same thing twice? And so we return to where this story began. A boat crew, staring at smoke rising from open water, certain they were watching a disaster. They weren't. They were watching Earth do something it rarely lets anyone see. Build a world from nothing, then hand it over to whatever life was patient enough, lucky enough, or airborne enough to find it. Perhaps Surtsey's greatest discovery was never the island itself. It was the proof that even now, on a planet we think we've already mapped and measured completely, Earth is still making new ground, and life is still finding its way there. 63 years ago, a fishing crew looked at smoke rising from the sea and thought they were watching something die, a ship burning, a disaster unfolding. They were wrong. They were watching something being born, and in the decades since, that birth has quietly answered one of the biggest questions in science, not through massive experiments, not through supercomputers or laboratories full of equipment, just through patience, through leaving one island alone long enough to watch it teach itself how to live. Bacteria that arrived on the wind, a single sea rocket rooted in black sand, spiders floating in on threads of silk, birds carrying seeds nobody thought they could carry, rewriting rules scientists had trusted for generations. None of it was planned, all of it was allowed to happen, and maybe that's the real lesson sitting inside this story. Not that Surtsey is unique because it's protected. Surtsey is unique because we let it be. We stepped back, and Earth did what it's always done, quietly, patiently, without asking permission. It built a world from nothing. Somewhere out on the mid-Atlantic ridge right now, the same forces that created Surtsey are still moving, still pulling, still waiting, which means this story isn't really finished. It's paused. And whether we get to witness the next chapter depends entirely on whether we're willing to watch and not touch. If this story pulled you in the way, it pulled in the scientists who first saw that smoke rising from the ocean. Subscribe, because Earth is still full of stories like this one, still unfolding right now, in places most of us will never think to look.